G'day and welcome. Have you ever considered what might happen if our planet, Earth, faced a catastrophe so immense that it threatened the very existence of humanity? It sounds like the plot of a blockbuster science fiction film, but it is a question that scientists, engineers, and visionaries are taking more seriously than ever before. The idea is simple yet profound: creating a backup of humanity, a second home away from home. This isn't just about exploring new worlds for the sake of adventure, but about preserving our species, our culture, our knowledge, and our history. Just as you might back up the important files on your computer to an external hard drive or the cloud, some of the brightest minds on Earth are proposing we do the same for our entire civilization. The logic is compelling. We live on a single, fragile planet, vulnerable to a host of dangers, from asteroid impacts and supervolcanic eruptions to man-made disasters. By establishing a self-sustaining human presence elsewhere in the solar system, we could guarantee that no matter what happens on Earth, humanity would have a chance to survive, and perhaps one day flourish again. Why is this conversation happening with such urgency right now? For centuries, the idea of living on other worlds was confined to the pages of fiction. Today, however, we are at a unique crossroads in history. Our technological capabilities are advancing at an exponential rate, making missions that were once impossible seem achievable. Simultaneously, our understanding of the cosmos and the potential threats it holds has grown, painting a clearer picture of our own vulnerability here on our beautiful blue marble. The threats we face are diverse and very real. We are becoming increasingly aware of the potential for a large asteroid or comet to collide with Earth, an event that could trigger a global winter and mass extinction, much like the one that wiped out the dinosaurs 66 million years ago. When we look to the heavens for a potential second home, two celestial bodies consistently emerge as the top contenders: our closest neighbor, the Moon, and the enigmatic red planet Mars. Each offers a unique set of promises and challenges, sparking a vigorous and fascinating debate among scientists, engineers, and space enthusiasts. The choice between them is not straightforward, as it involves a complex calculation of risk, resources, and long-term viability. This decision will fundamentally shape the future of human space exploration for centuries to come, defining our first tentative steps into becoming a multiplanetary species. When we look at pictures of Earth from space, we see a stunning blue marble, vibrant and full of life. It looks strong and permanent, but this beautiful image hides a delicate truth. Our planet, and the civilization it supports, is surprisingly fragile. One of the most significant threats comes from within our planet itself. Supervolcanoes, like the one slumbering beneath Yellowstone National Park, pose a colossal danger. An eruption of this magnitude would be unlike anything modern humanity has ever witnessed. Then there is the risk of a truly global pandemic. We have all recently experienced how quickly a new virus can spread across our interconnected world, causing immense disruption and loss of life. But what if the next pathogen was even more contagious or far more lethal? Looking beyond our own planet, we find that, we live in a cosmic shooting gallery. The solar system is not an empty, peaceful void. Instead, it's filled with asteroids and comets, remnants from the formation of the planets, zipping through space on their own orbits. The most famous example, of course, is the asteroid that struck the Earth around 66 million years ago. This rock, estimated to be about 10 kilometers wide, caused the extinction of the dinosaurs along with roughly 3/4 of all plant and animal species on the planet. An impact of similar scale today would be an extinction-level event for us. The initial blast would be catastrophic, but the secondary effects, like a global firestorm and a decades-long impact winter, would make the planet's surface almost completely unlivable. While safeguarding our species against extinction is the most powerful argument for backing up humanity, the reasons go beyond mere survival. There is a deeper, more profound motivation rooted in the very essence of what it means to be human. Throughout our history, we have been explorers, innovators, and pioneers. Think of the incredible technological innovation that would be spurred by such an ambitious undertaking. The challenges of keeping humans alive in the harsh environments of the Moon or Mars would force us to develop revolutionary breakthroughs. Furthermore, becoming a multiplanetary species would fundamentally change our perspective on ourselves and our place in the universe. Looking back at the pale blue dot of Earth from Mars would reinforce the preciousness and fragility of our home world. When we consider the monumental task of establishing a human backup, the Moon presents itself as the most logical and immediate starting point. Its most compelling advantage is its sheer proximity to Earth. Situated just 384,400 kilometers away, it is practically in our cosmic backyard. We also have a unique historical advantage when it comes to the Moon. We've been there before. The Apollo missions of the 1960s and 70s provided us with invaluable first-hand experience and data. We have walked on its surface, collected rock samples, and studied its environment up close. Finally, the Moon offers an unparalleled platform for science and observation. A base on the lunar surface would provide a stable, atmosphere-free location for powerful telescopes, allowing us to gaze into the cosmos with unprecedented clarity. For any off-world settlement to be truly self-sufficient, it must be able to live off the land, a concept known as in situ resource utilization, or ISRU. The most significant discovery is the confirmation of water ice located in permanently shadowed craters near the Moon's poles. Another significant danger is the lunar dust, or regolith. This is not like the soft sand we find on Earth's beaches. Billions of years of micrometeorite impacts have pulverized the surface rock into a fine, abrasive powder with sharp, jagged edges. Despite its proximity and resource potential, establishing a permanent home on the Moon would be an immense struggle against a relentlessly hostile environment. The lack of atmosphere creates extreme temperature swings and constant radiation exposure. While the Moon is our logical first step, for many, Mars represents the true prize in our quest for a second home. The red planet has captivated the human imagination for centuries, a distant, ruddy point of light that has long been a source of speculation about extraterrestrial life and future human settlement. The most compelling feature of Mars is its potential to be more Earth-like. It possesses a thin atmosphere, primarily composed of carbon dioxide. Furthermore, the Martian day, or Sol, is 24 hours and 39 minutes long, remarkably similar to our own 24-hour day. For those who dream of a truly self-sustaining second branch of human civilization, Mars is the ultimate prize. The goal is not just to establish a small research outpost, but to eventually terraform the planet, transforming a cold, dry desert world into a new blue-green marble. Just like on the Moon, the long-term success of a Martian colony hinges on its ability to use local resources to become self-sufficient. In this regard, Mars is a world of incredible promise, boasting a wealth of materials essential for sustaining a human presence. The single most important resource, water, is present in vast quantities. The Martian atmosphere, though thin, is another invaluable resource. It is composed of 95% carbon dioxide. Using technologies like the MOXIE experiment on NASA's Perseverance rover, which has already successfully produced oxygen from the Martian air, colonists could generate a steady supply of breathable air. The Martian soil contains the essential nitrates and other compounds needed for plants to grow, making it a viable medium for agriculture once water is added. With access to abundant water, a useful atmosphere, and nutrient-rich soil, Mars presents itself as a world with all the fundamental building blocks needed to support a large, growing, and ultimately independent human civilization. For all its promise, the path to establishing a human presence on Mars is fraught with immense challenges, far exceeding those of a lunar settlement. The single greatest obstacle is the sheer distance. Mars is, on average, 225 million kilometers from Earth, nearly 600 times further away than the Moon. This vast distance creates what is often called the tyranny of the launch window. Because of the way Earth and Mars orbit the Sun, a favorable launch opportunity only comes around once every 26 months. Once colonists are on Mars, they are on their own for years at a time. Once on the surface, colonists will face an environment that is deeply hostile to human life. The surface pressure is less than 1% of Earth's, so a tiny tear in a spacesuit would be instantly fatal. And then there are the planet-girdling dust storms that can last for weeks. The profound challenges of a Mars settlement lead to a fascinating and honestly pretty complex question. Would a Martian colony, separated by distance and time, eventually evolve into a new and distinct branch of humanity? The immense difficulty of traveling between Earth and Mars means the colony would need to become truly self-sufficient very quickly. Over a much longer timescale, there is even the possibility of biological divergence. Generations of humans being born, living, and reproducing in Mars's 38% gravity and higher radiation environment could lead to evolutionary changes. We could be setting the stage for the speciation of humanity, creating two distinct human species, one adapted to Earth and one to Mars. By reaching for the Moon and Mars, we are not abandoning Earth, but embracing a larger destiny for humanity. When we place our two contenders, the Moon and Mars, side by side, the comparison boils down to a classic strategic dilemma. Do we choose the safe, close option or the ambitious, distant one? The Moon's greatest strength is its proximity. Being just a 3-day journey away makes everything simpler, cheaper, and safer. When we compare the resource landscapes of the Moon and Mars, the red planet appears to have a decisive advantage. Mars appears to be a much wetter world overall, with widespread availability of water making large-scale agriculture and fuel production significantly more feasible. Beyond the technical and resource comparisons, we really have to consider the human element. What would it actually be like to live on these worlds? And what are the long-term prospects for survival and societal development? Beyond the immense technical and scientific hurdles of establishing an off-world backup, there are profound ethical and social questions that we must grapple with. One of the most immediate questions is, who gets to go? The initial missions will have extremely limited capacity. Furthermore, there is the issue of planetary protection. When we travel to Mars, a world that may have once harbored life and could potentially still have microbial life hiding beneath its surface, we run the risk of contaminating it with Earth-based organisms. Then there is the question of governance. How would a new society on the Moon or Mars be ruled? The legal framework for a permanent self-governing off-world settlement is completely uncharted territory. This grand debate is not just a theoretical exercise, it's happening right now, with real hardware being built and real missions being planned by space agencies and private companies around the globe. NASA is leading the charge with its Artemis program, an ambitious international effort to establish a sustainable human presence on the Moon. While NASA focuses on the Moon, private companies, most notably SpaceX, have their sights set firmly on Mars. Elon Musk's vision is to make humanity a multi-planetary species, and the company is developing a fully reusable transportation system called Starship to achieve this. China also has a robust lunar program with plans for a crewed lunar landing in the 2030s and a joint international lunar research station. Other nations and private entities are also contributing, developing rovers, landers, and scientific instruments. We stand at a remarkable crossroads in the story of our species, a moment where the age-old dream of living on other worlds is colliding with the technological means to potentially achieve it. The debate between establishing a human backup on the Moon or on Mars is more than just a technical comparison. It is a profound conversation about our future and our identity. The Moon offers the pragmatic path, a close and logical next step, where we can learn the vital skills of off-world survival. Mars beckons with a far grander, more audacious promise, a world that offers the tantalizing prospect of a second Earth and a new independent branch of human civilization. The blueprints are being drawn, the rockets are being built, and the missions are being planned. The Artemis program and SpaceX Starship are turning abstract ideas into tangible hardware, bringing the dream closer to reality every day. Ultimately, the question of whether we back up humanity and where we choose to do it may be the defining challenge of the 21st century. It is a choice that will test the limits of our ingenuity, our resolve, and our ability to cooperate as a species. Whether we choose the Moon as our stepping stone or leap directly for Mars, the act of reaching out into the cosmos is an act of profound hope. It is an investment in a future where the story of humanity is not confined to a single fragile planet, but is written across the solar system and beyond. The dream is vast, but it is a destiny that, for the first time in history, we have the power to shape. Our cosmic insurance policy awaits. The question is not if, but when and where we choose to write the next chapter of human civilization among the stars.